Right, good morning and welcome. My name is Boaz. I'm a product manager with Red Hat ACS team, and with me is Adi.
Hi, I'm Adi. I'm from IBM Research, working on open source projects for cloud networking resources.
And today we're going to talk about Kubernetes Network Policies, the challenges, and present and demonstrate as promised an analytical solution that was developed by the IBM research team in a project called NPGuard. We integrated it into StackRox, Red Hat ACS, and we're going to show you how that works. And at the end, Adi will actually show you a comparison that she did recently, because this was developed like a year ago. How does that compete with AI tools? Or can AI do the job? So before we jump in, well, if you're here, you probably know something about Kubernetes network policies, but how many people would say they're familiar with network policies? Terrific. Well, thanks for coming. Well, we'll just do a quick reminder. Even if you've been working on this for a while, it's often that you need a reminder, but for the people who are not on the day-to-day, Kubernetes was designed to be simple. As part of that, it was decided all communication is allowed. Just to get to work. Very quickly, it was realized by the community that this presents a significant security threat. Without data segmentation, with no limits, you're more exposed to data leakage, unauthorized access. Obviously, it makes it easier for lateral movement, penetrate a pod, jump to the other, denial of service attacks. So way back in 2017, the community developed this specification for Kubernetes Network Policies, which is a pod-level firewall that allows you to restrict pod-level communication. It's implemented by the CNI plugin as opposed to the Kubernetes core. Now, the concept of the network policy model is it focuses on the pod. It is a namespace resource. It talks about what do I want to allow my pod to do. I can specify for TCP, UDP, and SCTP which ports I allow for ingress and which I allow for egress. And the source and destination are specified for a port, a namespace, or a pod, or a namespace, or a pod in a namespace. The specification also allows you to talk about external communications with IP ranges, somewhat limited, but some capabilities are there. So if you look at the concepts that network policy introduces, there's first the question of scoping. So the policy scope is done through a selector, as I just mentioned. The policy can select a pod by label, or it can select an entire namespace. And then there are rules. For the rules, you also have selectors, and they select pods by labels, or namespaces by labels. There are two policy types, ingress policy and egress policy, and the same network policy can be one or both. Now, the same network policy resource can select multiple pods. The thinking here was, I want to be able to centralize my policy, just put the policy in one place, apply to multiple pods. By the same way, a pod may then be selected by multiple network policies. So this does create a many-to-many relationship with already kind of starting to feel the complexity there. Now, because all the communication was allowed by default, the introduction of a network policy flips the switch. As soon as a network policy selects a pod, all communication for that pod from that point on is denied by default. You have to explicitly allow a particular connection from that point on. But this is per pod and per policy type. If I have an ingress policy for my pod, all my ingress becomes denied by default. My egress is still allowed by default. And network policies are additive. So the good thing about it is there's no conflicts. You just continue to add. Again, remember, you start by denying everything, and then you start to add more and more connections that you want to allow. So 7 years later, raise your hand if you're applying network policies in practice. I'm honestly impressed. I can tell you that a lot of our customers are struggling, and I can see some handshakes in the room. So this is why we're here today. It's easy to get lost without tooling, and there is no tooling built into Kubernetes or OpenShift for that matter. There are some tooling associated with other network plugins. But these are complex concepts, right? First of all, there's no notion of connection. We want to think about can A talk to B, but in order to allow that, the specification has to make sure that both sides agree to that communication. And it's at a pod layer. It completely ignores services. It doesn't care about services, which is something that we do think about. Flipping the switch, that scares people. Because I just allowed one port, but all of a sudden it breaks another. I don't know that I'm ready to do that. I'm not even sure that I know what communication needs I have for my application or somebody else's application in the same namespace. So it's really, you have to do the math. In order to just figure out what are the rules that apply to a particular pod, you have to do the math, sum up all the policies that select the pod, or even ask yourself, where is the policy or the policy rule that is responsible for this connection being allowed or denied? Very difficult question to answer. Now, beyond that, going into the YAML spec, that's not for the faint of heart. There's ingress and egress policies within there's ingress and egress rules. And what happens if you mix them in the wrong way? You select a pod or a namespace. If you select both, is kind of a difference of a semicolon pretty much between the two, has a big impact. You have the from tags and to tags. What happens if they're missing? No tooling makes this very difficult. In addition, all of network policy didn't have a lot of backing up behind it because people thought that it was also limited or restricted. There's no exclusions. There was lack of cluster control at all. This is now addressed by AdminNetworkPolicies, and base admin will touch upon that. And the dependency on the CNI. So what if there was a tool that allowed you to create network policies automatically, in fact, analyze that? And you'd be shocked to hear that that's what we're here to talk about today. So IBM Research, with an open source project called NPGuard, developed this capability. At Red Hat, we integrated this into the StackRox, or Red Hat ACS, CLI. So we call this ROX Cuddle Netpol, and it is a set of tools. Now, the nice thing about this is it doesn't require ACS to run in the background. It's completely standalone. You can use it. It's just download the CLI and you can start using it. And with this toolkit, you can generate network policies, visualize the connectivity of a given environment. We can analyze overexposure, understand within a given connectivity environment, because of network policies and your deployments, where are you overexposed? You can understand who to blame, which rules are causing that connectivity, and you can even identify differences between two different projects. So diving into that a little bit, the way this works is, as an input, we take the root folder, or set of folders that contain all your YAML resources, including network policies, if there are any. And the logic is we start looking at the services. By looking at the services, we identify the destinations for ingress, and then we scan all the resources for connection hints. Now, if your application follows best practices, this is good enough. We've run this demo on many projects, and it typically just works. You can see here in the example, the config map, there's a shipping service port. That's enough for us to pick up that hint. So the features that are supported are, on policy generation, we will generate default deny on the entire namespace, tight connections for only those connections that we identified that are needed. We included support for DNS. If we see a deployment that requires external access, we will automatically enable DNS, and you can control which DNS port. On the analysis side, we show the connectivity map, which tells you these are the connections that your application is asking for. More than that, we can then analyze that and tell you that with a given network policy, you allow those connections, but you're actually over-allowing. And when we generate, we may not have enough detail to make it tight, but we will recommend for you to make it tighter. And we support a number of visualization formats. In fact, we also support a focus capability to analyze only one of your networks so you can focus. We have advanced analysis tools that allow you to explain the rule stack and a tool to show the difference between two folders. So as you're working, imagine you're changing your application, you're changing a network policy. How easy is it to understand what exactly changed? It's very difficult, and what we do is show you those connections that have actually changed. So, demo time. I'm going to be juggling between these windows. So let's see how that goes. Right, so first thing is we're gonna start with this online boutique application. It's a well-known Google application that somebody at Red Hat actually adapted to make it work for Red Hat. And the first thing we're gonna do is generate the network policies. And this is live, but again, it's static. So we're calling rockscuttle netpol generate, we're specifying the DNS port. OpenShift uses 5353 on the pod port, even though the service port is 53. So that's confusing. And let's see what that gave us. So one long file has all these multiple network policies, and it's actually going to be easier to see that in the slide itself. So I hope that you can see that it's not too small, but on the left, we have a policy that selects the cart service and allows it to have egress towards Redis cart. On the middle, we have the Redis cart policy that allows ingress from cart service. So this is what both these policies together are required to allow connectivity from Redis cart into cart service. On the left, you can see the DNS port that we added, and on the right, you can see the default deny. So as soon as this policy is applied in the namespace, all communication is denied by default ingress and egress. So now let's see if the network policy that we created makes sense. Before I apply, so I have a live cluster, I want to see if add service can talk to payment service. And what I did was I scraped the IP address of payment service. And we can see that OCXEC from add service, and I'm calling NC. We can see that the connection is allowed. Add service has no business talking to payment service, believe me. So we're going to apply that and just running OC apply off that file that we just saw. And we're going to try that again, and now we can see that it's timing out. Okay, so the network policy is doing its job. And I'm jumping a little bit ahead of myself, so let's make sure that the policy didn't break something. So I want to come in here and show you the app. This is the application. It's online boutique, and it looks like it's still working. So with that part, we're done, and we still don't know what it looks like. So we're going to ask rockscuttle to generate the connectivity map. This is rockscuttle netpol connectivity map. We're creating a DOT format, and let's see what that created. DOT, you have multiple extensions for that. Sorry, you can have that run in your VSC. You can have it run offline as I have now. And we do see here a basic representation of your application needs. If you compare this to the demo application, you'll see that it actually looks pretty similar. So you can get a sense of what's going on. Again, what we're showing here is these are the connectivity needs that we see based on the deployments and on the network policy that is now present in the same folder. All of this is static analysis. So we're done with this use case, and we're going to move on to the next use case, which is how good is my pod isolation? Let's go right into demo mode. And the first thing we're going to do is we're now going to extend monitoring into OpenShift monitoring by using AdminNetworkPolicy. This is what an admin network policy looks like. We're going to allow it on all namespaces for these 3 ports. And I'm going to apply it to my cluster. So if I just want to see what that looks like, by the way, here are the network policies that you can see in OpenShift. It's basically just a list. There's not much. You can go into YAML. Similarly, for admin network policy, it's in a different menu. It's a custom resource. So I wanted to give you a sense of, this is really what you get out of the box. There's not much more than that. But now we can analyze the exposure that we have using netpol connectivity map with this exposure flag. So now when we look at the output, it's going to look a little different. Let me just enlarge that here. OK. We can see the green connections that we had before. But now what you can see here is some interesting facts. Take a look at this UDP connection here. We can see that we know it's DNS, but it's allowed to the entire cluster. And that's probably not a good idea. You want to make sure. We don't know, just by analyzing those artifacts, what the DNS pod is, something that you want to tighten down. Incoming ports from 8080 into front end is open to the entire cluster. Do you really need that? What about OpenShift monitoring? We allowed that on purpose to all pods. You should tighten that down. You should make it only specific to the pod that you need within OpenShift monitoring. So just, again, this is a tool to allow you where your overexposure is and give you an opportunity to tighten them down. And with that, we'll go to the 3rd use case. And here's, again, the question of, help me understand what's going on. Why is this particular connection blocked? Why are my apps overexposed? We just saw the how. It's a really hard question. And we have 2 tools to allow you to help you with those. The first, as I mentioned, is a connectivity diff. I'm not going to be able to demonstrate it with the short time that we have today. But we will show you visually which connections have been added, removed, or changed, which new peer has been added to the mix or removed for the mix. And that's quite different than just looking at and trying to figure out the diff between 2 different files. There's no way you're going to figure that one out. Now, for explainability, this is, again, the ROX Cuddle connectivity map command with the explain flag. And what we do is we go over all possible connections across all the protocol port ranges with everything that we see. It's quite an elaborate matrix if you imagine what we're trying to do. And we combine all that knowledge with AdminNetworkPolicy to show you the rule stack that made something be allowed or denied. Looking at that format, just coming and preparing for today, it's really difficult. And so with a little bit of AI formatting, we got a much better result, and I want to show you what that looks like. First, let's run the command. Connectivity map. I did do it on a focused workload, so not to overwhelm. And this is what is generated. So you can get the sense that information is probably here, but it's really hard for a human to follow. So just again, all I did was ask cursor to reformat, and I specifically said, don't add any logic, which initially it did want to do. It's just plain reformatting. Here it is, just an MD file. So you can see that that's the output of the tool. It's the connectivity list, front-end connectivity analysis. From front-end to add service. Why is it allowed? Because front-end network policy has an egress rule that allows it, and add service has an ingress rule that allows it. But UDP is denied because even though it's allowed by front-end netpol, but ingress is denied. So this could be a potential for further analysis by AI. And if I'm just going to switch back, I can close this one down. And this brings us to the question of, what can AI do for us? Like, is all of this elaborate toolkit really too much? And this is where Adi will share her findings with you.
We wanted to check how far we can get with LLMs in generating, analyzing network policies. So we asked an LLM to generate network policies or analyze connectivity based on input network policies. Used a single prompt with instructions in natural language and giving it also the application YAML manifests. Did not use any model refinements, no pre-training, no tools, just pure LLM, single prompt. Tested with a few LLMs, Gemini, Llama 4, Microsoft Copilot, defined scoring, and analyzed the results and compared it to NP-Guard. So I did this experiment on 3 open source demo apps for which we have the known required microsegmentation in front of us. These are the reference architecture, so we can compare the generated connectivity to these references. So first, let's discuss about generating network policies. The input for this prompt was the app YAML manifest, the services, the deployments, the config maps, everything relevant. And scoring was for 3 categories. Does it create policies with correct syntax? Does it create tight segmentation? And is it not too tight? Does it not break the app? So for the syntax and best practices score, we have here 3 graphs, 1 for each app, and on each graph we have 4 columns, 1 for NP-Guard, and the other 3 columns are for the LLMs that were tested. And we see that NP-Guard has no syntax issues. LLMs sometimes do create policies with syntax issues that cannot be used as is. So I had to manually fix those policies to continue with the experiment. Then for the tight segmentation score, we can see that NP-Guard has the highest scores, of course, and the LLMs, some of them are not as good for this task. Gemini here had a high score. And then for the not breaking the app score, again, NP-Guard has high scores. The LLMs also have some issues. Some of them are creating policies that break the app. For example, here Gemini has low score. It created the required connections only in one direction, only in the ingress or egress, but not both. So it has a default deny and opens only ingress or egress. The required connection is blocked. So to summarize common issues that I've noticed with the policies that the LLM was generating, it has syntax errors, it has incorrect label key values for label hallucinations. It created policies only in one direction instead of both ingress and egress. It was sometimes missing default deny policies per namespace, or sometimes it was adding 2 permissive policies, like allow all per namespace, and it was sometimes missing port sections in the generated policies. So for these experiments, we could not use the policies as is what the LLM has generated. And then we wanted to check whether LLM can understand connectivity. Can you tell me about, good insights about the connectivity from the input network policies? So for this, there was a single prompt with input of the YAML manifest of the application plus the network policy YAMLs. The scoring categories was now for 1 basic question, can A talk to B on a certain pod? It's a yes-no question. Second question, give me the list of all allowed connections. Can it list all the allowed connections correctly? And third question, does it have false positives? Does it also list connections as allowed even though they are denied? And another experiment here for quality of explanations. Can it explain me why a connection is allowed or denied clearly and accurately? So this is the result graph for the first question. Is A allowed to talk to B on a certain port or not? It's a yes-no question. The results are pretty high, but not perfect for all LLMs. For the connection list, all LLMs were able to list all allowed connections correctly, did not miss any allowed connection. but some of them had false positives and were listing connections as allowed, even though they were denied. And as for the explanation, LLM can provide very detailed explanation, sometimes too detailed. But can we trust the explanation? Is it correct? Is it accurate? So one example that I noticed, it was confused by a bias from external documentation, probably. This is my assumption. There was a rule that allowed egress to all namespaces on UDP 53, so pod A could, in fact, send egress to pod B on this port. But the LLM claimed that it was blocked because this rule is only exposing to DNS servers, which was not what the rule has configured. So to conclude, in this experiment, the policies analysis and generation was not good enough by those models that we used. With admin network policies, it can get even worse. It's much more complex reasoning. We could get it better probably with more training, with stronger models, but this still may not be sufficient for complex scenarios. So we believe that combination of analytical tools like NPGuard and LLMs can be more promising, like using this as tools for agents, and this requires further investigation and research.
So in conclusion, thank you, Adi. There's a call for action here because we know that a lot of people have deployments that are not really isolated. Now, network policy is here. It's been here for many years, and it's not going away soon. These are the tools that we have. With Rockscuttle NetPol, you can make things better. You can introduce that into your organization. It's a developer toolkit. You can automate. What if you use Rockscuttle to generate the network policies, create a PR, have the developer with a starting point? Then they can review and approve. If they need further analysis, you saw these advanced analysis tools. You need to start mandating network policies as part of every project. Work with policies, something that ACS does easily, is it checks. It does it easily. It's actually not easy, if you remember, to just even answer the question, does this pod have a network policy that applies to it? That's not an easy question to answer, easily answered with ACS. Mandate those, manage your network policies as code in the pipeline, apply them early in your dev, move on to test, always keep them up to date. And then leverage AI for what it's good for. So if any questions, would people please step up to the microphone so that the recording can capture you. And while we're looking at that, there's the feedback form that we'd love to hear your feedback on the session. Go ahead.
So what about advancing the tool set to do more than look at complete YAMLs, but maybe review, or I guess you could Helm template out charts and do those sorts of things to get a complete YAML, but being able to take things like customize bases and Helm chart bases and analyze those with a similar tool set.
So it's true. I think people heard the question it's nice that we look at the YAMLs, but can we take a step back and analyze the source, kind of the Helm charts? You would need to have a preparation step today with the code that's there. You need to just put it all out in a folder. It is a bit of a limitation. And NPGuard is an op source project, and people it would be great if people can contribute, but there's no concrete plan for that right now. Thank you.
My question is pretty simple. Do you also support other, CNIs like, say, AWS's or Cilium or Weave or whoever? So, do you support their extensions?
Yeah. So the nice thing about this is it's pure Kubernetes spec.
Right.
So yeah. So I guess if you're asking, do we understand other CNIs which have their own languages? The answer is we don't right now.
No, well, they extend the Kubernetes. I believe they extend it, yeah.
They extend it.
Yeah.
So
you don't, but the answer is no.
we're, in terms of generation, we're just going to generate network policies.
Right.
In terms of analysis, I guess we won't understand any of those queues, and we might even fail. Yeah, we're probably going to fail. So I guess that's a no.
All right, thank you.
Hey, great presentation. Does the tool help maybe analyze performance impacts to network policy, like CNI performance impacts, things of that nature yet?
So because this is a static analysis tool, it just looks at your resources. There's no performance analysis whatsoever as part of this.
Is there anything like on plan for that, or?
Not within this tool set. Again, it's designed to work in a developer environment and be simple and easy to use. So there are no plans to. There are other tools within OpenShift. You have network observability, which is quite an elaborate operator. Even within ACS, you can get a sense of the connections. You have like a baseline that shows you who's talking to who. That's quite useful. In terms of performance, you probably want to look at the observability and those kind of tools.
Thank you.
Great presentation, guys. So I understand that this helps you define and see what your policies are, but how do you know that you have the right policies or those policies are sufficient, especially when you're talking to like the CISO or the governance side of the business?
So what this gives you, first of all, it's not going to be perfect. It's not a proof that everything is working. That still stays with the developer team. It does get you started. You know that it's sufficient because things continue to work. It's not breaking, but you don't know that it is tight enough. And for that, we give the exposure analysis option so we can show you where you're overexposed. The team would need to go and do the work and make it tighter.
Thank you.
Thank you.
Hey guys. So when you apply, let's say, network policies, what are the options to know? What would you recommend to see if you've broken anything, right? Like, what kind of feedback have you seen? Like, usually I would think you can do this from the metrics if there are blocks or connection drops are now happening from one application to another. What would you recommend there?
So if I understand your question correctly, like you feel that maybe this is not sufficient. It's not the full-blown solution, and you're probably right. It does get you started. In fact, it's quite elaborate. So if something is not working, you now have the capability to analyze the stack and actually see why something is denied, which otherwise you wouldn't be able to know. So this tool does help you with that. But if teams, and we've had teams like we're telling people, hey, you need to ship network policies, and teams are going, well, I'm not sure that I know what my application needs to talk to. I don't know if other people have seen this problem. And we can't help with that problem. Teams need to know their connectivity needs. Again, something like ACS, the network graph view, really helps you see who's talking to who after some time. So that gets you a good starting point.
Got it. Thank you. Another thing, like if you're already using, let's say, Istio or like some sort of mesh, is it beneficial to also use network policies? Like, what has your experience been?
That's a question, and we might have to cut this short, but it's a question we've seen. 1 minute? Okay, so we've seen the question about Istio. Honestly, if you're using your Istio, you may not need network policies at all. Actually, some people say the opposite. I don't know if anyone in the audience has a different opinion. We can have a talk later.
It just kind of builds off of that.
And maybe that's the last question, I think. Yes.
Do you support Gateway API?
We don't understand Gateway API. Only ingress and egress.
Only ingress controller, like the ingress resource or route resource, but not Gateway API.
Yeah.